So we start with new topic, and this is the current carrying conductor. Wait for 1 minute. Okay. Yeah, this is the next topic, right?
Yes, sir.
Okay, so you can start the next topic, current carrying conductor. Current carrying conductor in magnetic field, right? In magnetic field, right? Current carrying conductor in magnetic field, right? Suppose suppose this is the current carrying conductor, and there is a magnetic field. If you consider the current is I over here, right, and it is placed in a magnetic field B, right, the magnetic field B. So the force, the element, you can consider this is the current carrying conductor, and the length is, elemental length is L, this is the I, and the B, magnetic field is B present over here, right, at angle, some angle theta, you can say. So the elemental force is equal to what? Df is equal to I is dl cross B. This is the magnetic force on this elemental wire. Is it clear or not? How to consider this, right? How to do this? Listen one thing. Suppose there is a wire, and the area of the cross section is what? Suppose A. The current flowing is I. Are you getting or not? The length of this conductor is assumed to be L. All right. And you may assume that the magnetic field is acting perpendicularly, you can say. Is it clear or not, you tell? Right. Magnetic field is perpendicular to this board. All right. So if you consider the current I is flowing here, the value of current is NEAVD, right? I is equal to NEAVD. If you consider the electrons are, right, flowing or moving with the speed, drift speed in the opposite direction. Is it clear or not, you tell? If you consider a conducting wire, as this is the conducting wire, in conducting wire, if current is flowing, so the free electrons are the charge carrier, right, and which are moving or which are running inside the material, inside the conductor with the speed Vd. Is it clear or not? So you may consider that this charge electron is present in the magnetic field and it is flowing. So what do you know? The force will be acting upon this, right? The force, the magnetic force acting upon the charge, moving charges Q V cross B. Is it clear or not, you tell? Now if you consider this the magnetic field, right? The magnetic field inside, the direction of velocity is in this direction. So the force should be acting upon on this electron, the downward, but it is negative charge. So the force on one electron will be acting in this direction. Is it clear or not, you tell? Right. So listen one thing. If you want to find the net force, what is the force? Right. The force on moving electron, right? Moving electron. What is the force? Is equal to QVB. Drift is V is the drift velocity, right? B is the magnetic field, and the charge is Q. So EVDB. Is it clear or not, you tell?
Yes.
This is force on one moving electron, right? If you consider this is the conductor having the length L, and the N is what? Say number of electrons per unit volume or per unit meter cube. Area is A, length is L. What is the total number of electron? Total number of free electrons N is equal to number of electron per unit volume multiplied by the volume of this wire or conductor, right? So the total number of electron, therefore the total magnetic force will be what? Total magnetic force on the conductor on conductor. Please tell, the magnetic force is, this is the on one electron, and total number of electrons are what? N. So multiply by the force on one electron. Is it clear or not? So the magnetic force is what? What is the number of electrons total? Say N A L, right, into E V D B, right. So you may rewrite is N E A V D, right, into L into B, right. And what is NEAVD? Say the current. ILB. Is it clear or not, you tell? This is the case when the magnetic field, right, is perpendicular to this length vector. Are you getting or not? Magnetic field is perpendicular to the length vector. Are you getting? And if you consider, if there is an angle, there is some angle, right, angle between length vector and the magnetic field vector, right. So how would you find the force? The force will be equal to Q VD cross B. Is it clear or not, you tell? Drift velocity cross B, and it will be the minus E over here, the charge. Yes. This is the force on the one electron, and the total number of electron is this or not, you tell? Yes. Right. So VD, and if you consider the elemental portion of the length DL, is it clear or not? Elemental portion length DL, right. So the magnetic force may be written as I into DL cross B, where the I is the current, DL is the elemental vector, and the B is the magnetic field, right. So if you want to find the net magnetic force, you have to integrate this. So I DL cross B, right, is the total magnetic force on the wire. Do you understand this? Yes. Copy this. So listen one thing, if this integration is taken as inside DL cross B, right. So this DL vector is what? What is this DL vector? First of all, make a correction over here. This is the vector B, right. This is the elemental force on the elemental portion. But if you consider, if you want to find the net force on this elemental wire, suppose this is the wire, right, like this. The current on this wire is I, and this is the portion A, and this is the portion B, right. And the magnetic field is present like this somewhere. The direction of the magnetic field may be anything. So this, if you are considering this is the DL vector, right. So what is the integration of DL vector, you tell? The integration of DL vector is nothing but DL vector, this is small element, this element. So it will be equal to the, right, AB vector. This is equal to the L effective vector, right. L effective mean the line joining initial to the final position of the wire. So this is the L effective wire, right. Therefore the magnetic force on this wire AB, where the magnetic field is present B, right, is equal to I into L effective cross B. Is it clear or not, you tell? Yes. This is the magnetic force on the wire, right. So this L effective is nothing but line joining initial to the final position of the current carrying wire, right. Copy this. Yes, it is not displacement, it is similar to the displacement. Listen one thing, if this is the wire, listen, if this is the 1 vector, 2 vector, 3 vector, 4 vector, 5 vector, like these are the vector, right. So if you add all the vectors, what will you get? The equivalent vector is this. Do you know? The vector A plus vector B, right, like this, AB plus C plus D vector. AB vector plus BC vector plus CD vector is equal to what? Say AD vector, right. AB vector plus BC plus CD plus DA, AB plus BC plus CD is equal to what? Say A into D vector. This is AD vector. In the same way, if you choose this is the elemental vector, right, then this vector integration mean addition of this vector plus this vector plus this plus this plus this plus this plus this. So all the elemental vector when are added, so what will you get? You will get the AB vector, or you can say this is not displacement, rather the total vector, the summation of all this length vector is nothing but equal to AB vector, right? Yes. And this is called the effective length of the current carrying wire, right? Copy this. I will give you some illustration, then you will understand. So let's see one example. For example, if this is the length is equal to 10 centimeter, right, and the current carrying in this wire is what? 2 ampere. Is it clear? The magnetic field is B into the board and the value of B is 0.5 Tesla. Are you getting or not? Yes. Find magnetic field acting on this wire, on this current carrying wire, right? So what is the formula? Please tell. F is equal to ILB sine theta, right? ILB sine theta or IL cross B. But the length vector is in this plane. So this is the L vector and the magnetic field is perpendicular. So here the theta is 90 degree in most of the cases, right? The angle between the length vector and magnetic field vector will be 90 degree. So the magnetic force you may write it is equal to ILB. So current is 2 ampere, length is 10 centimeter mean 0.1 meter, magnetic field is 0.5, right? So this is equal to what? 2 into 0.05, right? 0.1 Newton is the correct answer. All right, copy this. So read this question. In this question, a wire band as shown in figure, right, the magnetic field is out of the board. All right, like this. This is the magnetic field and this magnetic field is out of the board, and place in uniform magnetic field that emerge from out of the plane as shown in figure. So this is the wire. The wire start from here. This distance is R. The current goes like this in a semicircular loop, and this is the I. Is it clear or not? Yes. This is the R, right? And this distance is 2R. So this is the initial point, this is the final point B. To find the force, what you have to do? ILB sine 90 over here, right? Sine 90 is, although you will remember the formula ILB. So this L is nothing but effective length. What is the effective length, you tell? Line joining initial to the final position. If this is the A, this is the B, right? Join that. So what is the effective length? R plus 2R plus R. So the effective length is equal to 4R, and the current is coming from A and going to the B. Is it clear or not, you tell? Yes, sir. What is the value of current? Say I. So now this wire of length 4R, right, is placed in the magnetic field which is coming out of the board, right? Also the force, magnetic force on this current carrying wire is given by L effective into B. So what is the direction? What is the direction of the magnetic force? Along it is given by the L cross B, or it may be found by the Fleming left hand rule again, right? Yes. For example, the magnetic field is out of the board. Yes. And current flowing is like in this direction. Yes. The magnetic force will act upon this downward direction, right? So on this wire, the magnetic force act in downward direction. The current is I into 4R into B. So the magnetic force is 4IRB. Is it clear or not, you tell? Yes. Right. Copy this. So read this question. in this question, a square of side 2 meter is placed in a perpendicular magnetic field and the B value is 2 Tesla in a direction perpendicular to the magnetic field to the square inward, equal current I. Okay, the current I value is 3 ampere flowing in the direction as on the figure. Find the magnitude of the force on the loop. Right, what is the side of the loop? It is 2 meter. Is it clear or not, you tell? So there in this loop there are three wires. This is the one part, this is the second part, and this is the third part. Is it clear or not? And the magnetic field is, say, into the board. Are you getting? Yes. Magnetic field is into the board. So if you consider the name of this is A, right, C, D and E, like this. Is it clear or not? Yes. So if you consider this AD part, the AD part, right, current is like this. If it is 2 meter, 2 meter, so what is its length? Say 2 root 2 meter or not, you tell? So how to find the force? ILB sin 90. Magnetic field is into the board. This is the direction of the current. So force on this AD portion will be acting in this direction or not, you tell? So this is the magnetic force F2, I can assume. The magnetic field is what? Say into the board. So the magnetic force is nothing but ILB, right? ILB sin 90. What is the current? 3 ampere. It is 3. The length is 2 root 2. The magnetic field is 2. So 3 duni 6 duni 12 root 2 Newton. You understand this thing or not, you tell? Yes, sir. Now if you consider this is the first portion. What is the first portion? This is the initial point A. Current start from here, reach it to the C, it turns and reach it to the D. So wherever the wire go does not matter. Its effective length is what? Line joining A to D. So what is the effective length? Its effective length. This is the effective length. Is it clear or not, you tell? Yes, sir. So this wire portion ACD can be replaced the wire by AD. Same wire AD. And the current start from A and reaches to D. Right. So and the length, effective length, if it is 2 meter, 2 meter, what is the effective length? Say root 2 meter. Right. And the same force you will get. The F1 and F2 are equal. Is it clear or not, you tell? Yes. In the same way, if you consider this portion AED mean this is A, current start from here, E, and this is the D point. Is it clear or not, you tell? Yes. Wherever this wire goes does not matter. The thing is that the initial and final position you have to, so the equivalent length is nothing but equal to again the AD, right? So this wire third portion can also be replaced by this wire AD, and the length is 2 root 2 meter, and this is the magnetic field, this is the current, the magnetic force will be F3. So F3 will be same as F2. You understand or not? So what is the net force? What is the total? Yes, total force is nothing but F1 plus F2 plus F3, and both are equal to 3 times of 12 root 2, 36 root 2 Newton. The force will be acting on this loop, and the direction of the force will be along this direction. Is it clear or not? Yes. This is the net force 36 root 2 Newton. Is it clear? Yes. Copy this. So read this question. In this question, a wire of length 5 centimeter is placed inside the solenoid near its center. Suppose this is the solenoid, right? This is the axis, or you may assume this is the center. And when the current in the solenoid is supposed to be I, right? The wire carries a current 5 ampere, and the magnetic field due to the solenoid, listen, if this current capital I flows over here, so due to solenoid, what is the magnetic field produced? Although it is equal to mu naught Ni, but its value is given already in the question, and the magnetic field produced due to solenoid is 2.5 into 10 raised to a minus 2 Tesla. Is it clear or not? Now a wire is placed over there. The wire length is, suppose this is the wire, right? This is the wire. What is the length of this wire given in the question? 5 centimeter. Make an angle 30 degree with the axis of solenoid. This is the axis of solenoid. And what is this angle you tell? 30 degree. This angle is 30 degree. So the magnetic field and the length vector are inclined at 30 degree. Is it clear or not? And this wire carries a current. What is the current in this wire is 5 ampere. Right? So if this wire is placed in the magnetic field of this solenoid, so what is the force on this solenoid? ILB sine theta. Is it clear or not? You tell. So what is the current in this wire? In this wire the current is, say, 5 ampere. What is the length of this wire? 5 centimeter. The magnetic field due to solenoid axis 2.5 into 10 to the power minus 2, and the theta is sine 30. Sine 30 value is 1 by 2, right? 25 into 10 to the power minus 4 into 2.5 into 1 by 2. Is it clear or not? 25 625 बटे 2 into 10 की पावर minus 4, 31.25 into 10 की पावर minus 4 Newton. Right? So which option is the correct option, you tell? The magnetic force may be written as 3.125 into 10 raised to a minus 3 Newton or 32.2, right? So the B option is the second option is the correct option. Is it clear? Copy this. So read this question. In this question, wire Ln. This is the wire Ln, right? This is L and this is N. Placed in the perpendicular magnetic field. The magnetic field is out of the board and it is equal to 5 Tesla, right? And a 10 ampere current flows. What the value of the current? Say 10 ampere. So we have to find the magnetic force such that its length is what? Say 4 centimeter. It is 6 centimeter. It is 4 centimeter. Is it clear or not, you tell? So now to find the magnetic force on the wire placed in the perpendicular magnetic field, what you have to find? You have to find the effective length. What is the effective length? Tell me. The effective length is found, yes, line joining initial to the final position. So the effective length is this. Is it clear or not? So you may assume this is the N, you may assume this is the L. So this is the effective length and you may assume the current emerges from L, right, and reaches to the N, right? This is the current. So can you find this length? Yes, we can find this length. How? This is what? This is 6 centimeter and this is 4 plus 4. This is 8 centimeter. So the value of Ln is nothing but root over, right, 6 square plus 8 square. So this is how much you tell? 36 plus 64 is equal to 100 is equal to 10 centimeter is equal to 0.1 meter. So the length of the wire Ln is 0.1 meter. Now the magnetic field is out of the board, right? So the force will acting in the first direction or in the second direction we have to find, and the force is equal to what? Say ILB sine 90. The current here is 10 ampere. The length is what? You tell. 0.1. And what is the magnetic field value? B. And sine 90 is 1. So this is equal to 5 Newton force. And what is the direction? Please tell. This is the left hand, right? Magnetic field. And this is the current. Magnetic field, this is the current. The force is what? First or second? This is the magnetic field. This is the current. So what is the direction of magnetic force? It is first. Sometime it become very tough to do with your left hand. So what will you do? If the magnetic field is in the upward direction, for meantime you can assume the magnetic field is in downward direction into the board. This is the magnetic field into the board. Suppose take your left hand into the board. This is the direction of current. So what is the direction of force on this? Yes, force, if the magnetic field is into the board, force is coming in this direction, but actually the direction of magnetic field is in out of the board. So if for the out of the board, the magnetic force will act in this direction. Is it clear or not? Otherwise sometime it become very tough to do like this, right? How to do? So this is the direction of the magnetic force. Is it clear or not? Although only the magnitude is asked, right? Copy this. So read this question. In this question, if a wire ABCDEF with each side of length L bent as shown in figure. What is the figure? Suppose this is the x-axis, y-axis, and this is z-axis. All right. As shown, and the current I, if placed in magnetic field V, which is parallel to the y direction. Okay, listen one thing. The magnetic field is along this direction. Fine. And this is the wire, right? A, and this is the wire B. Fine. This is B to C, right? This is C to D, right? This is D to E. Then it is F. Are you getting or not? You tell. The length of each wire, suppose this is L, this is also L, this is also L, this is also L, and it is L. Is it clear or not? You tell. The magnetic field B is in the direction of J cap. Fine. So if a current carrying wire is placed in the magnetic field, then magnetic force acts upon this, and the magnetic force is nothing but I L effective cross B vector. Is it clear or not? You tell. So it is the starting point, it is the final point. So wherever it goes does not matter. Only if you want to find, suppose this is the y-axis B magnetic field, right? So to find the effective length, just join A to F. Yes, this is, suppose this is A, this is F, join that. The current coming from A and is going to the F. Is it clear or not? You tell. This is the current. Fine. So what is the AF length? L. This is the AF length, right? L. Listen one thing. The direction of current is in which direction? You tell. Along the x-axis. So L effective vector over here is what? Magnitude is L. And what is the direction? X-axis. So I cap. Is it clear or not? So the magnetic force on this current carrying wire on A, B, C, D, E, F, whatever it is, the magnetic force is nothing but I into L I cap cross B J cap. Is it clear or not? You tell. So what is the magnitude? Say ILB, and the direction is given by I cross J. What is I cross J? K cap. So it is ILB into K cap. This is the magnetic force vector in Newton, and its direction is along along z axis plus z axis. Is it clear? So which option is the correct option, please tell? So the first option is the correct option, right? Copy this. So read this question. In this question, a current I flowing through a wire PQR. This is the wire P, Q, and this is R. All right. This is PQR, and this angle is 60 degree. The magnetic field given in this question, this direction, this length, right? According to figure, length PQ is given as L, and the angle PQR is 60 degree. Then the ratio of the magnetic force on PQ divided by magnetic force on QR. This ratio we have to find. Is it clear or not, you tell?
Yes.
So if you consider the wire PQ only, right? Suppose this is P, this is Q, the length is in this direction, the magnetic field is in this direction. Is it clear or not, you tell? So what is the angle between the length and the B vector here? Say 90 degree.
90.
So what is the, if I assume to be the F1 and F2, right? F1 and F2 magnitude. So what is the F1? Say current is I, L B sin 90. Is it clear or not, you tell? The force, magnetic force on PQ wire is equal to what? Say ILP. Fine. Now we have to find the force on QR, right? So how to find this, please tell? This is the QR. Suppose the length is L dash of this wire. So first you have to find the length L dash. What is L dash? Cos 60 is equal to what? Base upon hypotenuse, right? It is equal to 1 by 2 L upon L dash. So what is L dash? Say 2 into L. Is it clear or not, you tell?
Yes, sir.
So if you consider this the Q and this is the R, so this length is nothing but L dash. Fine.
Yes.
And the current coming I like this, because this current goes, this is the I current, then it goes this side, right, along this direction. Is it clear?
Yes.
So what is the current? Say current is I coming from Q reaching to R, right? So this is the length L dash vector, and tell me, if this is the L dash vector, L dash magnitude is 2L, this is the magnetic field vector, this is the L dash vector, this is the B vector. This angle is what? 60 degree. It is 30 degree. So it is 30 degree. So what is the angle between L dash vector and the B vector? Tell me. 30 degree. So the magnetic force F2 on QR will be equal to what? I L dash B sin theta. Is it clear or not, you tell?
Yes, sir.
I, what is L dash?
2L.
What is the magnetic field B as it is? And sine 30. So 2ILB into 1 by 2. Sine 30 value is 1 by 2. 2 will cancel out. It is equal to ILB. So the force on this wire is same as that of force on the wire PQ. So magnetic force on PQ and the ratio is ILB upon ILB is equal to 1:1. All right. So which option is the correct option? The fourth option is the correct option, right? Copy this. So let's see another concept, right? That is force between magnetic force, right? Magnetic force between two long current carrying wire, current carrying wires. All right.
Yes.
So in this case, we will consider the two case. The case 1, what is that? Current is along, current are along in same direction, right?
Yes.
For example, if this is the wire, it carries the current I, and the another wire, it carries the current I2. Is it clear or not?
Yes.
And the separation between them is what? D. Is it clear or not?
Yes.
So if you consider this is the I1 and this is I2, fine. So if you consider this the I1, the magnetic field is produced into the board this side. Because of this, suppose this is the current wire at distance D. What is the magnetic field produced over here?
Into the board.
Yes, this is the wire 1. Due magnetic field, you will write magnetic field produced due to wire 1, B1 is equal to what? Mu naught I1 upon 2 pi d, or not, you tell?
Yes, sir.
2 pi d. And at this point the another wire is present. Is it clear or not?
Yes.
So if you consider the L length of this wire, suppose this is the L length of the wire, all right?
Yes.
So now this wire, L length of this second wire, this is the second wire, present in the magnetic field of the first wire, right? So the magnetic field is into the board.
Yes.
Magnetic field is into the board. In this wire, current is I2,
Yes.
and the force will act upon this wire here. This is the force on wire 2 due to 1 representation, right? So since the wire 2 is placed in the magnetic field of wire 1, therefore magnetic force due to magnetic force on wire 2 due to wire 1 on its length L, right, represented by force on 2 due to 1 is equal to ILB. I'm assuming its length is L, although it is long, but only on the length L we are finding the force, right?
Yes, sir.
ILB, whose current will be written here? Tell, I1 or I2?
So it will be I2.
Yes, I2, because this is the portion placed in the magnetic field of B1. The magnetic field is B1 over here into the board. I2. Length L and magnetic field due to wire 1. So it is written as I2 L mu naught I1 upon 2 pi d. All right. Now it may be simplified. F2 comma 1 is equal to mu naught I1 I2 into L upon 2 pi d. Is it clear or not? Copy this. So this is the force on wire 2 on the length L, but they don't ask the force on the length. Rather, if you divided this force by L, so mu naught I1 I2 upon 2 pi t, right? So this is the force, this is the in Newton, and this force is nothing but Newton per meter, right? So, are you getting or not?
Yes, sir.
In the same way, if you consider this is the separation D, this is the wire 2, current I2 is in this direction. So because of this wire, the magnetic field is produced out of the board. So here the magnetic field is produced, right, B2 out of the board. What is the B2? Mu naught I2 upon 2 pi d. Is it clear or not, you tell?
Yes, sir.
if this is the magnetic field out of the board,
Yes.
right? And now you consider the L length of the wire 1, right?
Yes.
And the current is I1 in this direction.
Yes.
The magnetic field is in this direction.
Yes.
This is the current.
Yes.
So where the magnetic force will act upon this wire? Towards right. So on this wire the magnetic force will, this is the force on 1 due to 2. Is it clear or not?
Yes.
So in this wire, because of this portion, the magnetic field is produced outside. If you consider the length L, right, I1 is the current. So force on 1 due to 2. Force on 1 due to 2 will act in this direction. If you consider the same length L, suppose, of the wire 1, so what will be the force on 1 due to 2 is equal to ILB. What is the current I over here? I1. And what is the magnetic field? Whose, in which magnetic field it is present due to, produced due to the wire 2? So it is 2. So it is I1L. The B2 is, this is the B2. Mu naught I2 upon 2 pi t. So the F1 comma 2 is equal to mu naught I1 I2 upon 2 pi d into L. Is it clear? So F1 comma 2 upon L is nothing but mu naught I1 I2 upon 2 pi t. So is this same force or not, you tell?
Same force.
So what does it mean? If there are two long parallel wire like this and the direction of current is same, right? Current flows in the same direction, they will attract each other, right? Therefore I'm writing this side, right? After this you can, therefore if current flows in same direction, current flows in same direction, right? Both wire will attract each other, right? Force of attraction will be there, and force per unit length is, you have to remember, mu naught I1 I2 upon 2 pi d. D is the separation between them. Fine.
Yes.
Right, copy this. In the, now we will discuss the case 2 in which current flows in opposite direction. Current flows in opposite direction, right?
Yes, sir.
Opposite direction. So current flows in opposite direction mean, if this is the one wire, long infinite wire, this is the another wire, long infinite wire, but the direction of current is what? Opposite. It is I1, it is I2, and the separation between them is what? D. So if this is the one wire, this is the second wire, right? So this is I1 and I2, right? The current is in opposite direction. So because of this wire, the magnetic field is
Yes.
into the board. So this is into the board. Is it clear or not?
Yes, sir.
Right. What is the magnetic field? B1 is magnetic field due to wire 1, What is that? Please tell. Magnetic field due to wire 1, B1 is nothing but mu naught I1 upon 2 pi d. Right. Now if you consider the length L, right? Length L. Tell me. Magnetic field is into the board.
Yes, sir.
Magnetic field is into the board. Because of this wire, current direction in this direction.
Yes.
So what is the direction of magnetic force? Away, in the right side. Force on 2 due to 1, right? If you consider the length L portion, therefore force on 2 due to 1 is equal to what? Force on 2 due to 1 is equal to ILB, right? What is I? Whose current? Say it is I2, it is L, and the B1 is produced by 1. So listen, F2 comma 1 is equal to I2L. What is B1? Mu naught I1 upon 2 pi t. If you simplify, mu naught I1 I2 upon 2 pi d into L. Fine.
Yes, sir.
So this is the force on L length, which is away from this wire, which is repulsive in nature. But force per unit length, this is the force per unit length is equal to mu naught I1 I2 upon 2 pi d in Newton per meter. Is it clear or not?
Yes.
This is the force per unit length. Are you getting?
Yes.
Now, if you consider this is the second wire I2, and because of this I2 at distance, this is the current. Are you getting or not? Right. If the current is in this direction, what is the magnetic field produced? Into the board, right? This is the current into the board. So here the magnetic field is produces into the board, right? What is the magnet? The separation is D. The B2 is what? Mu naught I2 upon 2 pi t, right? Now if you consider the L length of this wire, the current flows I1. So what is the force on wire 1? Tell me. Into the board.
Okay. Yes.
Into the board. Current.
Yes.
So force will be in this direction. So force on wire 1 due to 2. Force on wire 1 due to 2, right, is equal to ILB. What is the I? The current flows. This portion of length L is present in the magnetic field of produced due to 2, right? So this is the B2 into the board here. Fine. Current is I1, length is L, the magnetic field is B2. It is equal to I1 L, right? B2 is what? Mu naught I2 upon 2 pi t. So F1 comma 2 may be written as mu naught I1 I2 upon 2 pi t into L. So force 1 comma 2 upon L, mu naught I1 I2 upon 2 pi t. The same force again is coming, whether current flows in the same direction or in opposite direction, right? On this wire also the magnetic field is produced, and if you consider the L length, force on this portion will be same, right, per unit length. But I'm writing this side, right? The force is away from each other, that is repulsive in nature. That is,
Yes.
I'm writing this side. Yes, if current flows in opposite direction, the wires will repel each other. Is it clear or not? Or you can say the repulsive magnetic forces produced. Is it clear or not? You tell.
Yes.
When you see the long wire in the fields, right? Have you seen when you are passing through the highways, the long wires are there, right? So they are at some separation. Why there are some separation? Because the current flows on those wires in the same direction. So if you consider the two wires, so they will attract each other. So the attractive force acts, right? So that is why they are hinged by, or they are tied by some supports over there, so that they don't touch each other. Is it clear or not?
Yes.
Copy this. So read this question. In this illustration, a current of 10 ampere flows in two parallel wires, right? The direction of current is not given, right? But the current is 10 ampere, 10 ampere. You can assume in the same direction. And they are separated by some separation, magnetic force on each, right? So the magnetic force per unit length, on each wire is given as minus 3 Newton per meter. Is it clear or not, Yutal?
Yes.
And what is that value? Mu naught I1 I2 upon 2 pi d or not, Yutal?
Yes.
D is the separation, I1 I2 is the current. Now, if their current makes double, the current makes double, and separation them makes half, D by 2. So what is the magnetic force per unit length? You have to tell. Is it clear or not, Yutal?
Yes, sir.
You understand the calculation?
Yes.
2 2 ja 4 and this 2 come in the numerator. So 2 into 2 into 2 into 8. 8 into mu naught I1 I2 upon 2 pi d. Right. So the force per unit length, new force per unit length become 8 times of the initial force per unit length. So what was that? It was given 2 into 10 ki power minus 3 Newton per meter. So it becomes 16 into 10 ki power minus 3 Newton per meter. Is it clear or not, Yutal?
Yes.
So the first option is the correct option, right? Copy this. So read this question. In this question, 3 long straight wire current carrying like this. This is the 2 ampere, 4 ampere and the 6 ampere. So they are asking the magnetic force on the Q. This is the Q, P, Q, R. And what is the length of this wire is taken? And the length is L is equal to 10 centimeter. Is it clear or not, Yutal?
Yes.
The separation between them is also given 2 meter and 2 meter. Are you getting or not? So listen one thing. If you consider this the I1 and I2. So both direction is the same direction. So if you consider the PQ, it will attract or not, you tell.
Yes.
And in the same way, it is same direction.
Yes.
So if you consider that this the two wire, it will attract also not.
Yes.
So what is the force per unit length formula? Mu naught I1 I2 upon 2 pi d. Right. So if you want to find the force only, then you have to multiply mu naught I1 I2 upon 2 pi d into L. Is it clear or not?
Yes.
I assume to be this L3. So this is the force 1. Tell me.
Yes.
Force 1 is applied by the wire P on wire Q.
Yes.
If you consider this is the wire, the force will be attractive. This wire will attract this force.
Yes.
Force per unit length is what? Mu naught I2 I3 upon 2 pi d or not, you tell.
Yes.
So what is the F2? Mu naught I2 I3 upon 2 pi d into L. Please tell you are getting this or not.
Yes.
Tell me which force is greater? F2 or F1? This force is greater or this force is greater? Tell. Say F2 is greater. This is greater. Why? If, yes, I1 and I3, because separation is same, everything is same. So if I3 is greater, so F2 is greater than F1. So therefore, what is the net force on this wire of length L? L is equal to 10 centimeter, is equal to F2 minus F1. The F2 is what? I2 I3 upon 2 pi d into L mu naught I2 I1 I2 upon 2 pi d into L. Fine. Mu naught upon 2 pi d. I2 into L is common. I3 minus I1 is left. Fine. So the net force on the wire Q. What is the mu naught value? 7. It is 2 pi into d. D is what? Tell me. 2 meter. I2 into, what is the value of I2? 4. And what is the value of L?
0.1 meter.
10 centimeter mean 0.1 meter. I3 minus I1, 6 minus 2. Right. So this 4 pi will cancel out. 0.1, it become minus 8 into 4 into 4. 16 into 10 to the power minus 8 Newton is the correct answer. All right. So which is the correct answer? 16 into 10 to the power minus 8. Towards right.
Yes. Right.
Towards right.
Yes.
Right mean the net force in this direction. Fine. Copy this. Now, if you consider, suppose this is the wire I1, and this is the small wire of length L. It carries the current I2. Fine. And the separation between them is what? Say D. Right. The wire is placed parallel to this infinite long wire. So you have to find the net force. Find net force on wire BC, AB. Although we have done this, right? How to find? This is the current. What is the magnetic field produced over here? This wire is placed in the perpendicular magnetic field.
Yes.
B due to, this is the wire 1.
1.
Wire 1. Mu naught I upon 2 pi d. This is the current I1. Fine.
Yes.
Then this is the magnetic field.
Yes.
This is the current I2.
Yes.
The wire of length, the length of the wire is L. So force will be acting on this wire 2 in this way. Therefore, force F2 on wire AB, ILB. What is the current here? Say I2. What is the magnetic field? B1. I2L mu naught I1 upon 2 pi d. So F2 is equal to what? Mu naught I1 I2 upon 2 pi d into L. Fine.
Yes.
Copy this. So now take another example. Suppose this is the current carrying wire I. The current is I1. Now the wire is placed like this. The length of the wire is assumed to be L and it is at distance A. The current in this case is I2 and this is I1. This is the infinite wire. Right?
Yes.
So this wire name is AB. Find magnetic force. Magnetic force. Right. Find magnetic force on wire AB as shown in figure. Right? Copy this. So how to solve this question? Listen. This is the infinite current carrying wire and because of this wire AB is placed in the magnetic field. Right? The magnetic field, suppose this is the A and B, it is the magnetic field everywhere. But this magnetic field is not constant. In the previous question, when the current is like this and this is the wire I2, so magnetic field was at distance, it is constant. But here as the distance is changing, the magnetic field is changing or not, you tell. So what will you consider if this is the distance x? Right? And this is the small portion of the width dx. Right? As distance x, you consider the small portion of width dx. Is it clear or not?
Yes.
So if a small portion you consider, what is the magnetic field at this point, you tell? mu naught I1 upon 2 pi x. Mu naught I1 upon 2 pi x. And this is the magnetic field into the board. Right. What is the direction of current? I2. So on this elemental portion, if you consider the elemental portion of dx, current is in this direction. So the magnetic force, elemental magnetic force will act upon this. Right. So therefore, elemental magnetic force df is equal to I L B. What is the I? The current is I2. The length is what? Say dx into B. The B is produced by this current I1. What is the magnetic field produced at this portion at distance x? What is the magnetic field produced at this point? Say mu naught I1 upon 2 pi x. So this is the elemental force. Do you understand?
Yes.
So this elemental force df is equal to mu naught I1 I2 upon 2 pi x into dx. Are you getting?
Yes.
So this is the elemental force. So there are so many elements starting from this is the element, this is the element, this is the element, this is the element. So the element start from util from x is equal to a.
Yes.
This is the element df vector, df vector, df vector. So we have to add all the df or not util. These are the df forces.
Yes.
So from where these elements start, x is equal to a.
Yes.
Up to what x these elements are present? A, yes, x is equal to b means this distance. What is this distance? A plus n. So you have to integrate to find the net force, right? Mu naught. You have to integrate this expression. And what is the value of x start? From a to a plus n. So the constant terms come out from the integration. Only 1 upon x dx remains there from a to a plus n. Is it clear or not, you tell?
Yes.
What is the integration of 1 by x? Integration, yes, very good. It is ln x. So it is equal to mu naught I1 I2 upon 2 pi ln x, and the limit varies from a to a plus n. Mu naught I1 I2 upon 2 pi. First put the upper limit, fine, minus lower limit. So mu naught I1 I2 upon 2 pi ln a plus upon a. So this is the net force on the wire AB. This is the net force on the wire AB. Mu naught I1 I2 upon 2 pi, fine, ln 1 plus L upon. This is the correct answer, right? Copy this. So let's see one another example. Suppose there is a wire of length L, right? This is the wire AB and its mass is supposed to be mg. Is it clear or not?
Yes.
So if this wire is released, suppose this is the wire, if it is released under gravity, what will happen? You tell.
Fall down.
It will fall down. So if there is a wire, this is the another wire infinity, and current here flows is I1. Are you getting?
Yes.
You have to find the height h. Sorry, you have to find this. This wire is placed, right? This wire is placed at height h. So you have to find the direction, find the magnitude, find magnitude and direction of current in wire AB, in wire AB, so that wire AB may remain in equilibrium, may remain in equilibrium. Equilibrium. What does it mean? You tell. It means if this is the I1, so there must be some current flows in the wire AB, so that the magnetic force acts. Suppose this is the magnetic force should act opposite direction, which balance its magnitude of the mg. Yeah, gravity force is balanced by this magnetic force. Is it clear or not?
Yes.
So if this is the wire, the current should flow from A to B or B to A. You tell. Listen, this is the current carrying wire. This is also the current carrying wire. The force should be repulsive or attractive?
Repulsive.
Repulsive. So the current should flow in opposite direction or in same direction? Opposite direction. So I1 is flowing in this way. So I2 must be flowing in this way. So this current I2 you have to find.
Yes.
So what is the direction? Direction should be direction of I2, right? From B to A. This is the first thing. How it is, we can verify. If this is the current carrying wire,
Yes.
because of this infinite wire, what is the magnetic field produced? Say out of the board or not?
Yes.
So here the magnetic field is what? Say out of the board. So the magnetic field produced due to wire 1. Can you tell me what is the magnetic field at height h? Say mu naught I1 upon 2 pi h, and out of the board. Fine. Now this is the magnetic field.
Yes.
This is the magnetic field, and this is the current direction.
Yes.
So what is the magnetic force in this direction?
Yes.
So therefore for equilibrium of wire AB, what is the condition? Condition is that magnetic force should balance by its gravity force. So what is the magnetic force? Say ILB.
Yes.
What is I? I is the current in the wire. The length is L. And the magnetic field is mu naught I1 upon 2 pi H. This is H. You understand or not?
Yes.
This is mg. So what is the value of I2? Is equal to 2 pi H upon mu naught I1 L into mg. Is it clear or not, you tell?
Yes.
Although they will give some parameter, one parameter should be unknown, right? Would be unknown, and you have to find that. But the concept is that because of its magnetic field, right? Magnetic force will be in such a direction, or the magnitude will be equal and opposite to the gravitational force.
Okay.
Also, you will remember, sometime it is very tough to find the direction. If the force is repulsive, right, then the direction of the current in two wire will be in opposite direction.
Okay.
Do you understand this?
Yes.
Copy this.